So this is a job. This is a remodeling project. We have the plates here for the columns. Plates for columns. It's like a 10 by 10. Here I say it's 10 by 10 by 10. You see the welding with moment connection welding. Moment connection. So the rotation is not allowed for this system, for this frame. The rotation of the beam is restricted by the moment connection over there with the plates on top and the bottom, as you can see it. For the walls, they have a partitions wall. This is basically working as partition walls. You have columns on this side, you have columns on that side. You have the beams here. Have columns on top here. This is a remodeling project. See, the bolting is already tightened. We can see it because the stick out is removed of the high strength bolt. This is a really nice slab system. You see the C joist. This is galvanized steel 50 KSI, 50,000 libras PSI. You see like it's a deck on top, and then you have the concrete lightweight. Usually it's lightweight. It's nothing structural. Walls, CMU walls, columns, steel columns. You have another steel column here, 10 by 10. And the thickness of the flange is like 1 inch. The web, I don't know, I will have to see. It's 1 inch. It doesn't reach 1 inch. I would say it's 7/8. It's 7/8. I would say at least 5/8 for the flange. I'm just trying to. It's thick. At least no less than 5/8. I would say 7/8 and 5/8, 10 by 10 column. You can see the structural system here. There it is. You can see columns going all the way to the top. So basically for this building, the CMU walls are partition walls. They are not receiving direct load of the building. The steel is doing all the work. Over there you see that's what you call moment connection. So the beam is going to be inserted in between these plates, and it's going to be bolted all around. 12 bolts on that side, 12 bolts on the other side, and you have two more in the flange. So you have 12, 14 AS high strength bolting for this beam. So that is a moment connection. The beam is restricted from deflecting because of the connection there. That the engineer uses the moment connection to reduce the height of the beam, because if you restrict the supports, if you close it, then you can lower the height of the beam. This is what they have so far. They have 4 inches slab over here. This is a remodeling project. Let's take a look. This is the way out. We're going down to the basement. See why they had done new here. The building was just reaching this part. They are extending the first floor. they have new walls, new concrete walls. Whatever they had before, they replaced it with new concrete walls. You can see the stone over there. But you have actually 12 inches concrete wall. Usually it is 12 inches wall, foundation wall with 2 layers vertical number 5 rebars, every 12 inches apart on center. That's the usual, that's the minimum. 12 inches, 2 layers vertical, 12 inches on center, separation, and number 4, 2 layers in inner and outer face with number 4, usually number 5 can be number 5, but you can use number 4, 8, 4th rebar number 4, raise 60, black rebar. You can use it as well for the horizontal, vertical number 5, every 12 inches, right? 12 inches thick, and you have a nice, really nice foundation wall. How long is this wall? I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 32 feet. 32 feet length for this basement. We asked how, I don't know, because I counted 16 marks. This is the mark for the formwork that was used to pour the new wall. And you have 2 feet width for the formwork. It is already removed. I counted 16 marks, 16 formwork. So it is, that would add up to 32 linear feet for this wall and 32 linear feet for that wall as well. We have a door here. You can see they haven't removed the hooks that they used to attach with the wedges, the formwork here. It's a Simon system. They haven't removed it. They are going to remove that because this is no use. Unless you have an inner wall, then you have a stud wall, stud 2 inches thick or maybe 3 inches, and you have every 16 inches you're gonna place a stud, galvanized steel, and you're gonna fill up the gap with the insulation. So you have this nice, beautiful wall here. It's insulates the basement, but on top of that, we're gonna add 2.5 inches, 3 inches more insulation, inside insulations, right? So these hooks may be removed or maybe not, but you will see later that they install 16 inches apart galvanized studs, 3.5 inches, maybe 2 inches. And the gap in between is gonna be filled with insulation, cavity insulation. Then you have the sheetrock on top of that. 1 layer, 5/8. I would say it's most probably only 1 layer because you already have all the insulation you have provided by the concrete and by the cavity insulation. So you don't need more of insulation for that. But it may be one layer 5/8 gypsum board or 2 layers. I didn't see the drawings, but I would say it's only 1 layer for this one. For the slab, we have here the same system: galvanized C-joist, every 16 inches, hanging from the steel with the hangers, right? And stiffeners. This is very important for the inspector to look up for these stiffeners to protect the ends of the C-joist from bending from the loads, right? So that's very important for the inspector as well to notice if they install stiffeners right there. See it? Okay. Well, guys, this is the end of the inspection. Let's go up. We need to go back to another place. They're grouting over there for second part. So thank you, guys. Thank you for watching my videos. Thank you for coming back to this channel. Ciao, ciao.